Chapter 7, Decision Structures, page 201. Simple decisions. We've got convert.py. And then we've got some pseudocode, an enhanced algorithm on 202 and 203, talking about if Fahrenheit is greater than 90, print a heat warning. If Fahrenheit is less than 30, print a cold warning. So we got the flow chart, 7.1. Let's create some Python code. The same way they're creating it. Let's use Atom. So here we go. Let's do convert to.py. Let's put that on the desktop. And we'll put that in Python. Oh. All right, let's call this convert3.py. Okay. Convert3.py, page 204, chapter 7, Zelle. This is second edition. Try to CS Python. All right, so we're going to do this program converts C to F, right? And it issues heat and cold warnings. Let's do main. So our function main, Celsius, eval input. What is the Celsius temperature? Okay. Fahrenheit. That equals 9/5 times Celsius plus 32. Print. The temperature is Fahrenheit. Degrees Fahrenheit. Print warning for extreme temps. Fahrenheit is greater than 90. Print. It's really hot. Be careful. If Fahrenheit so this decision structure is if and then if. I kind of like elif here, you know. Otherwise, if Fahrenheit is greater than 30, you know, since it's less than or equal to 90, you know, but Professor Zelle doesn't believe so. Based on on this code. Then we're going to invoke main to make sure that we call it, and then we'll see how it goes. Okay, so after telling, so convert 3.5, so it's up by, yeah, I think that works if I live. So let's do, so convert 3.py desktop. No. It's going to be the Python folder. All right, let's check this out. Okay, Celsius, Fahrenheit, parentheses. I think it looks pretty good. Pretty straightforward. Function definition, function body, or function header, function body, and then function call. Okay, so 76. Well, first thing I want to do is 21. Or we should address warmly. Okay. So it gives us the temperature, the degrees Fahrenheit. Let's run it again. Now we're going to try 90. It's really hot out there. If Fahrenheit is greater than 90 or less than 30. Not the Celsius, the Fahrenheit. So let's do 65. 149. Oh, wow. It's still hot. Let's do 0. Cold. I like if elif. Then we've got 7.1.2, performance of the conditions. If the condition is true, then we do statement, etc. And if it's not true, we just, so the control flow on page 205, expression, relational operator, and then expression. So less than, equal to, is equal to, greater than, not equal to. All right, so let's just play around with idle. All right, so let's just, so 3 minus 4, or 3 is less than 4. True, right? 3 equals 4 is syntax, is an error. Because it can't be equal to 4, right? Because that's an assignment. So 3 can't be assigned 4. A can be assigned 4, right? And then A can be assigned 3, right? And that's A. But 3, that is 3 equal to 4? And that is false. Is 4 equal to 4? That is true. How about the absolute value of negative 4? Is that equal to 4? That's true. So as we see on 206, 3 times 4 is less than 3 plus 4. That's false. Right, because 12 is less than 7. That's false. It's not less than 7. Let's do hello is equal to hello. What do you think? That's what I have to think about too. Is like, what do I think it's going to output based on what I've learned? Based on what I've learned up until that moment that I'm working on that project, or coding that assignment or question or whatnot. Like, that's a good practice. So I think it's going to be true. Right? Okay, good. And then if it's not true, if it doesn't fit what I think it's going to be, then I want to figure out, okay, now I want to remember this. So how can I remember this? Whether I write them on index cards and study them, use a Quizlet, these online websites where you can put all your notes and stuff and practice there. Um, you think about, acronyms. Um, there are a lot of memory tricks. So, and we'll go over those over time with this class and, potentially other classes as well. I'm a big fan of memory tricks. They definitely got me through, um, a lot of academic subjects. So, and I just think that it's important. That's important to focus on is how to recall, how your brain works and how to recall. So this is going to be false, I think. Yes. Well, if I'm looking at the book. Okay, so so capital H is less than, well, okay, now before I even look at it, or, okay, just looking at it, um, I remember that it's backwards from what I think. So usually I would think that small lowercase characters have a lower value than uppercase characters. However, not so in Python, and probably just in programming in general. I think that the ASCII character set, I'm pretty sure that it's across the board. These ordinal and hex values, they're all the same across all languages. So, but I remember this because it's outside of the ordinary. So I've somehow burned this into my brain. Capital letters come first, then small letters. So capital letters are smaller. One way I think about it is, okay, well, it's just an example too. I mean, there are a lot of things you might remember, but this is just an example of how I try to remember things. So capital letters occur less often in a text, right? Any article, any book, they occur a lot less, right? So they're not as quote unquote important. So they would be a lower ordinal value, right? And then lowercase characters occur a lot more, probably 5 to 10 times to 20 times more, 30. I mean, it's just a lot depending on how many titles, how many names, if it's a play, there might be a lot of capital letters with the character who's speaking, just the formatting. But just in regular text, like a regular book, it's probably got to be a 20, 30, 50, 80. I mean, that's definitely a data science question, which a lot of that comes from Python, but that would be a great question to ask. Based on what type of medium, um, what is the ratio between lowercase characters and uppercase characters? But that's just the way I remember it. So since uppercase characters occur less frequently in general, that they would of course have a lower ordinal value, and that's just the way I remember it. Even if it's not true, in the sense of why whoever put them lower made them that way. Even if that's not true, even if I don't even know what that is, I try to think in my brain how I can get there, how I can create these hooks in my brain, these flags, so when you're running a race that's just straight, you know, flat ground that's just straight, you know where you are in the race. You've got these flags that you've set up. And that's just like a memory flag. So anyways, the capital H is lower value than the lowercase h. All the letters are going to be the same, so this is going to be true. And there it is. Okay, so 7.1.3 example conditional program execution. And I got import math. And then here we go. So on 207, the math.__name__, you can see that when imported, the __name__, variable inside the math module is assigned the string math. Then it talks about sets the value of name to be main. So let's try it. Let's just do. There it is. It's main. And so if a module is imported, the code in that module will see a variable called name, whose value is the name of the module. And if the file is run directly, the code will see that name has the value main. A module can determine how it is being used by inspecting this variable. Putting the pieces together, we can change the file lines of our programs to look like this. If name is equal to main, then invoke the main function. Essentially, this guarantees that main will automatically run when the program is invoked directly, but it will not run if the module is imported. You'll see a line of code similar to this at the bottom of virtually every Python program. Okay. All right, so we've got two-way decisions, which we can go over in the next video. Thanks a lot.